All right, welcome to another episode of Spooky Software. Today is a very special episode. All the episodes are special to me, but this one in particular is special to me. I'm joined by my colleague, my friend, the late, the great Jasmeet. Hi, want to say hello to everybody?
Hello, it's nice to be here again.
Absolutely. So Jasmeet is a repeat guest. If you did not see her previous video, she came in as the expert on DNS. And ironically, we will be dealing a little bit with DNS today too, but not to the degree we were before. No, today instead we will be focusing on something that's close and near and dear to my heart, which is the tool Terraform. So today's video is going to be a little interesting because we're going to be using Terraform, as we will see, to work with AWS and deploy some infrastructure, but we will not be covering in depth how to use AWS or exactly what it is we're deploying or why we're deploying it the way we are or anything like this. That could be in and of itself an entirely different video, but today we're going to be focusing on really Terraform and not even exactly how to use Terraform, more so a general idea of why you would even bother learning Terraform or using it at all. This is sort of just more of a teaser for maybe an audience member who's working in operations or DevOps or something in this kind of realm and just is looking out there at what's available to them. With that in mind, we can kind of discuss. So Jasmeet came to me a few weeks ago, and she's like, "Hey, I want a portfolio kind of personal website thing, just a static website." And I think, Jasmeet, correct me if I'm wrong, you were using Gatsby or something to generate your HTML. Okay,
Yeah.
great. She has these static HTML files and maybe some CSS and some other things, and she just wants to put it on the web for public consumption, right? And she's like, how should I do this? And she ended up working with GitHub Pages. Is that correct? Okay, cool. But I was like, if you wanted to, you could use AWS and maybe get a little bit more performance or control or something like this. But because AWS is kind of a pain in the butt, even for something as small as this, maybe you want to use some Terraform, right? And Jasmeet, being the smart engineer that she is, she was like, I don't know about that. That sounds like a lot of kind of overhead, something like that I'm not that familiar with, just to deploy a couple static HTML files and some DNS. And why would I bother doing that? And I was like, well, Terraform can help you there too. So Jasmeet, with that said, I know you have a little bit of experience using Terraform on a large scale, right? At work, right? So maybe you want to illuminate your experience level before we move forward.
Yeah, so I worked with Terraform. I was actually introduced to Terraform working at Notarize. And at Notarize, we have a bunch of different environments. We use a lot of different AWS services for our infrastructure. So, I definitely learned from that experience why it makes sense to automate using Terraform. And, that was a good reason for me to learn how to use it. But I did notice that it is I have to learn a whole new language and learn how to configure Terraform and how to use the different providers and things like that. And so for someone with a website like mine who just wants to deploy some static files, I was wondering why is it even beneficial for them to learn all of this if they can just go to the AWS console and set up their one or two or four services manually.
Yeah. And to be clear, I don't think neither of us would object to somebody using the AWS console to deploy their little static website or whatever. It's more that we expect this to be sort of an illuminating example as to how this could grow in complexity and get out of hand. But I think even by the end of this video, maybe we will actually have some reasons to use it even on this very small scale. Yeah. So why don't we actually, Jasmeet and I, before the stream, I guess the recording is a better appropriate term, right? Before the recording, drew up a little diagram of what we're aiming for, right? So this is our desired output. So let me pull up the iPad like this. And so this is kind of a drawing of the jazzme.et infrastructure, right? And so each one of these boxes, so the large box on the outside is kind of the whole thing, right? That's everything required for this website. And then every one of these smaller boxes inside is something, a part of this larger infrastructure. So, for example, bound in the bottom left, probably the most important piece of infrastructure is an S3 bucket, which holds all this static HTML, right? So Jasmeet would generate this HTML and she'd like upload it to S3 so that it's like, publicly downloadable, right? But S3 doesn't have all the features she needs. It doesn't have HTTPS, right? Which everybody should be using HTTPS, including you on the interwebs. So she's like, okay, well, we'll put CloudFront in front of it, right? So that's what this bucket, this circle, this square in the top left is this CDN that is going to sit in front of S3. And so that enables us to use HTTP. CDNs also provide a bunch of other stuff like, geolocated DNS and low latencies and all kinds of things, caching, which is really nice for static websites or whatever. But again, so we get to all these benefits, right? And notice how we've drawn between the CDN and the S3 bucket, we've drawn an arrow. So I'll use this. So that's this guy right here, this arrow. And this is to indicate a dependency, right? So we have these two different things that we want, and there's a dependency. So the CloudFront CDN depends on the S3 bucket. That's why the arrow is drawn that way, because we need to create the bucket first so that the CDN has something to point at, right? So there's kind of an ordering to these things, right? And a dependency, a natural way in which these things need to go. So, Jasmeet, you were talking about using the console, right? Going to AWS.com or whatever and going into the console and creating these things through the wizards or whatever. You would need to mentally map this whole thing out and be like, well, I'm going to go create the S3 bucket first, right? And then I would go over to, CloudFront and I would create the CDN and I would copy and paste values over from the S3 bucket, maybe with multiple tabs or whatever, to like make sure that the CloudFront thing is pointing at the S3 bucket, right? And again, and you have some other squares here, other parts of the infrastructure. So in the top right, we have some DNS, right? We want some records for Jasmeet's domain name to point at our CDN. We want some records for SSL validation, right? So we have this certificate that we want AWS to sign for us that has Jasmeet's domain name. And again, that's what these arrows are indicating. There are some dependencies between these things. And additionally, we also notice that if we were to kind of topologically sort or order this graph, right? This is really a graph. Maybe some of these things could actually be created in parallel. So while, the S3 bucket or the CDN depends on the S3 bucket, so we need to wait to create the CDN until the S3 is ready. Like the SSL certificate, on the other hand, is kind of independent of those two things. So we could actually create the certificate and the bucket at the same time, for instance, right? And that would be, kind of a miraculous thing for you to do, Jasmeet, if you did it in the console. But I don't know, maybe you can. Do you have like some special capability you're not telling me about? So anyway, hopefully that at least answers your initial question there, Jasmeet.
Yes.
Yeah. And I think, you had mentioned this a little bit before when you're saying, oh, I've used Terraform on sort of a larger scale at work and stuff. The other thing, as we will see, is that, Terraform kind of allows you to write down. So we will see this exact picture. We will see it described in code, right? And this code is like, a text file that we can check into a repository. So Terraform falls into this kind of infrastructure as code, like family of tools where, we write things down as code. And not only does that help with documentation, of course, because we kind of write down, like, imagine, Jasmeet, you deployed your website in 2021, and then in 2023, you wanted to make a change, and you're like, I have no idea how it works, right? Because I did it 2 years ago, right? You at least have this text file that you can like kind of refer to and see, oh, this is actually what I did, right? You can also, send it through code review if you have a large team, all these other kinds of things, that kind of stuff. All right. So hopefully that answered more of the question.
Well, Eric, I'd love to see an example of the code.
Oh, yeah. All right. So let's go back to the desktop here, and we will take a look. So this is a Terraform file that Jasmine and I have prepared beforehand. And so this is a programming language called HCL. I don't think anything uses it except for Terraform, but it kind of looks like JSON ish. But this is a declarative programming language. That is to say, so there's no necessarily statements or ordering to any of these things. This is just kind of you write down what you want, and then Terraform will interpret it and try to enact that, right? And so this kind of stuff up here is just some configuration for Terraform itself. Providers, which we will talk about in just a moment, are kind of like plugins, and the only one we're using is the plugin to work with AWS. It turns out that Terraform is sort of cloud agnostic or even infrastructure agnostic. It doesn't care that you're using AWS or Cloudflare or GCP or any of these other things. Ultimately, what it's really working with are these dependencies and resources, and it doesn't care what under the sheets is managing or creating those resources. So here's an example of one of these resources. This roughly correlates to one of the each one of these resources roughly correlates to one of the boxes we were looking at in the diagram before. Some of these resources Jasmine and I have commented out because we don't want to deploy this during the video. We won't actually get AWS to sign our certificate. It requires some DNS validation that can take like 48 hours, so we're not going to do that today. But here you go. Here's an example. This resource is that bucket we were talking about. So this is the type of resource, and this is kind of like a variable name, a name for this thing, and you can give parameters. These are very similar to the things that you would, if you were using the console, you would type in, right? Or if you were using the CLI tool or an SDK, these are the kinds of parameters you would send to the actual AWS API. And so again, we're not going to delve too deeply into how to write this stuff or what every single one of these options actually means. But the idea is that I just declare what I want, right? So I want a bucket. I want it to have a website. I want it to have versioning enabled. I want it to keep files for 15 days. Again, here's my CloudFront distribution. Here's some properties about that. And here I want to point your eyes to this line. So this is an example of drawing those dependencies, right? So here Terraform can just read this TF file and recognize like, oh, well, for me to declare to create this CloudFront distribution, I need to first create this bucket because I need to know its website endpoint to point the CloudFront distribution at it. And again, because this is all declarative, I don't have to necessarily order these. I can have as many files as I want spread across as many subdirectories. There's no order to the code. Like just because line 67 happened before line 42, I could reorder these in the same file. It wouldn't matter. Terraform is going to sort of draw this graph that we were describing earlier in memory and manage that for us. We'll also, of course, detect like, circular dependencies and these kinds of things and complain at you if you have them.
So Eric.
Yeah.
So why can't or I guess like what would be the disadvantage if I decided to write like a shell script using the AWS CLI, and that's kind of, like a written down, I guess like I'll have a written down script of like, everything that I set up, or even like using like Ruby or like Python to use like the AWS SDK to set up all of these services. Like if I just ran that script or ran my program, how is, learning to do all of this going to benefit me instead of doing that?
Excellent point. So thus far, Jasmine, we've really only been talking about creation, right? So we're sort of saying, hey, Terraform, please read these TF files for me and create the resources that I want. But Terraform can do more than that. It can also manage change, right? So a script like you described is actually probably really great if you just want to create the thing once and then never change it, and can also, as you said, act as sort of documentation or like what I did or whatever, write it down, so to speak. But like imagine that like I want to, in a few years, like maybe HTTP 3 comes out, right? And I want to tell this CloudFront distribution like, hey, can you like bump the version that you're using to HTTP 3, right? That script will be a little problematic because I don't want to recreate everything from scratch with like that slightly changed parameter, like, this one line. I sort of want to keep most of what I have, and just like change the one resource or any dependent resources that need to, right? And so this is a really great point, Jasmeet, that when we write these things imperatively, there's no clear way to go from like state A to state B unless your original state is like empty, right? Terraform can do that very easily, and we will actually see a demo of that quite explicitly.
Cool.
I think also on that note, Jasmine, you were actually telling me before, one of the things you really liked about Terraform was how it helped find changes out of band. Maybe you can tell me about that. I forget what you were saying.
So, so when I used Terraform at work, a lot of our employees have access to the AWS console, and so sometimes they might like change like a rule on like an S3 bucket using the console. And I noticed that like when I was running Terraform, I could basically see when like these changes were being made.
Yeah.
Maybe that's thing we'll see later.
Yeah, exactly. So actually we can definitely demo that, and maybe we could do that when we do the change demoing. Is so because Terraform has to go from state A to state B, it kind of has to have a sense of what state A is, right, or what you currently are, and so it can alert you to like changes out of band, at least for the resources that it is managing, right? It may not help you manage all of your infrastructure forever, but at least the ones that Terraform is managing itself certainly can give you some like heads up, right? And I've definitely seen the same thing, Jasmine. Definitely. So let's try to get Terraform to work. So if I run Terraform, so this is just like, it's just a CLI tool. I think it's actually like a Go binary. It's very easy to install because it doesn't have any like system dependencies. You can basically just download the binary on any server anywhere and just like run it. If I do like help, I think so like Terraform actually has like quite a bit of commands that it can do. We're not going to, like I said, we're going to mostly kind of skip over a lot of this stuff. The only one that we really care about, the most important one, is apply, which is basically saying, hey, Terraform, kind of read your current directory, find all these TF files, and do your thing, right? We will also use it init, so you have to run this command before you do most of these other ones. This is what this does, and I'll do this right now. Is I think it does some basic validation of like maybe syntax errors and these kinds of things, but most importantly what it's doing is it's going to grab and download any of these provider plugins that we were talking about. There are lots of kinds of providers that Terraform can use. Like I said, it tries to be very agnostic, so all of your big cloud providers are going to have a provider, and this is basically the code that translates ACL into API calls for your particular cloud, right? That's usually what a provider does. But there are actually other kinds of providers, like, if you want to generate random numbers, or you have a file that is templated in some way and you want to like drop that file on a server you're deploying or whatever, there's a provider to do, like, I think it's kind of like Jinja type templates or whatever, these kinds of things. There's lots of providers out there. So again, the only one that we're using is AWS, which is like grabbing, some version that we specified, and it says, hey, I'm ready to roll, right? And so if I do Terraform apply, what Terraform's doing is reading all these this TF file that we have. We only have one in this case, and it's saying like, okay, well, the summary of what I'm going to do, and I have to like agree that I want to do this, is I'm going to create 5 new things, change none, and destroy none. And these numbers would, of course, change depending on what your current state is versus what you desire. But in our case, since we have nothing, it's going to create everything fresh. So that's what these little green things are. And you can kind of see. And Jasmine, back to your point earlier, look at this. See, these are the known after replies. These are computed values, right, that we can't necessarily know until things get out there. And these would be the things that you would copy and paste in the console, right? Because you'd have to like first create this thing to later copy and paste it into something else, right? And of course, here's all these resources. So again, each one of these roughly correlates to one of those boxes we were talking about earlier. All right, so let's try this out. And I canceled it because I didn't type yes, but we'll do it again. And this will take a couple minutes because, clouds are, especially something like CDN, takes a few minutes to deploy, but we'll pause the video and come back when it's ready.
So one thing before we pause that I want to
yeah.
is that this Route 53, if you go down, sorry, to when you right after you clicked apply. Click yes. Yeah. So it looks like the Route 53 zone route and the bucket started getting created at the same time.
Yes.
But the CloudFront distribution website didn't start getting created until after the website bucket. And I think that matches up pretty nicely with our dependency graph.
Exactly. Well said, Jasmine. Well said. All right. We'll come back when it's ready. All right. So it looks like everything's successfully completed. It took about, 2 or 3 minutes for everything to get out. And we can even see, here's another example of those dependencies you were describing earlier, Jasmine, where the CloudFront finished, after about 3 minutes. And then we created the records for that CloudFront after that fact. Which is great. So what we're going to do, Jasmine, this is a great idea that you reminded me earlier, is first of all, we can, just refresh the AWS console to show you that these things did get created. So here's that new static files Jasmine thing. But I'm going to be like a not so nice employee of Spooky Software Inc. And I'm going to go in here. I'm going to make a change. So I think under management, right? So we had this lifecycle policy of after 15 days, we delete old versions of objects. But I'm going to change this for some reason. I don't know why. I'm going to change it to, let's do 10 days instead of 15. Save this off. Oh yeah, I definitely acknowledge. I get it. Okay, great. So I made this change and Terraform doesn't know about this. It's not written in the code or anything like this, right? It just happened, right? And so at some later time, apply, somebody runs Terraform apply and says I want to, update the infrastructure to some new state. Now, in theory, we haven't made any changes to our TF file, so this should be a no op. But actually, we noticed that Terraform is complaining. It says, oh, actually, I guess not complaining, but it's saying, no, I need to change something. And it's actually specifying exactly what is changing here. So on this bucket, it wants to change the lifecycle from 10 to 15. And so this is exactly what you were describing, Jasmine. This is a Terraform kind of letting us know about a diff in our infrastructure for a resource that it is managing. And if I were to actually deploy this, it would just, again, modify this single bucket. It's not modifying the CloudFront distribution or anything like this. It's not redeploying all these things, which is, again, that advantage we had over that sort of script you were describing earlier is it can go from A to B. It doesn't, there's no imperativeness to this, right? And so, of course, if I refresh this and then just take a look at this, this should be back to 15, which is great. We did it. Yeah. All right. So I think that this is kind of all we really wanted to cover. This gives you a little taste of what Terraform does and how it works. Again, we didn't delve too deeply into actually using it, but we gave you hopefully a sense of why you would want to. And how these things can scale up. Jasmine was telling me before we started recording, she said, well, maybe if I had a staging to play, and I wanted to play some preview environment, right? So I could test out my changes before I release my public website. That would be nice. Well, with Terraform, you can have, kind of stamp out many of the same thing in a repeatable, declarative way and make changes to those things, without pulling your hair out, right? So anything else to add, Jasmine?
No, I think I've learned a lot, and now I understand why I might potentially want to use it for, deploying a static website, which is a relatively small thing. But I also understand that I don't have to.
You don't have to. That's right. The choice is always yours.
Yeah. So thank you so much for teaching me.
No, well, thank you for joining me, Jasmine. This has been fantastic. I love having you on the show. So, anytime you want to come back is just my pleasure.
Well, thanks.
All right. Well, have a good day, everyone.